Second half of the product rule and quotient rule video. We're going to be dealing with some trig functions on this one, so really I'm getting into the next section in our book. It's 3.3 for those of you in the class. Okay, essentially what I'm telling you is the derivative of sine is cosine, the derivative of cosine is negative sine. Those are two facts that are good to have memorized. Derivative of sine is cosine, derivative of cosine is negative sine. A lot of people confuse these and think the derivative of cosine is sine. It is not. The derivative of cosine is negative sine. You can talk yourself through those by looking at the graphs. All right, cosine, if you think about the slope of the tangent line, it starts out to at a height. The slope of the tangent line starts out at 0, so its derivative should start out at a height of 0, just like it does here. However, quickly as you move to the right here, the slope of the tangent line becomes negative. So the height of the graph of the derivative should be negative. The sine's not negative over here, it's positive. It should be down here. The derivative of cosine ends up being the negative of sine, not sine. At any rate, using those facts, you can come up with all sorts of stuff. You can figure out what the derivative of tangent is. How are you going to figure out the derivative of tangent? Well, tangent, as you may recall from Math 112 class, is sine over cosine. So really, when I ask you for the derivative of tangent, I'm just asking you what's the derivative of sine over cosine, and you can figure that out because you know the derivative of sine and you know the derivative of cosine, so you can use the quotient rule. Quotient rule, as I had jotted down up here for reference, tells you that the derivative of f divided by g is f prime g minus g prime f over g squared. So playing the role of f is sine of x, and playing the role of g is cosine of x. And thanks to this statement up here, I know f prime and g prime. The derivative of sine is just cosine. Derivative of cosine is negative sine. So I can take all this information right here. Sure, let's make it like it's a flow chart, I guess. And spit out the derivative of tangent. Let's see, using the quotient rule, I got f prime, which is cosine of x, times g, which is cosine of x, minus g prime, which is negative sine of x, times f, which is sine of x. Oh, and don't forget the whole thing is divided by g squared. So g is cosine of x, cosine of x squared. Open a textbook. I dare you. You will never see this anywhere as the derivative of tangent, because this is messy and you can make it pretty. The way you can make it pretty is you can say, wait, cosine of x times cosine of x, that's just cosine squared x, yeah? Yep. Minus and negative, isn't that the same as adding? Sure is. Sine of x times sine of x, that's sine squared x. Yep. Divided by cosine squared x. This is a little bit prettier than this, but we can go further if you happen to remember the Pythagorean identity. Tells you that cosine squared x plus sine squared x equals 1 for any angle x. The cosine squared of that angle plus the sine squared of that angle will always be equal to 1. So this is really just 1 over cosine squared x. That's considerably prettier than anything I had up here. And we'll actually take it a step further, because if you look in a textbook, you won't see 1 over cosine squared x. You'll see secant squared x. And 1 over cosine is secant, so that checks out. The derivative of tangent is secant squared. And I'll use similar logic to figure out all the rest of these derivatives. Let's see, cosecant, I would say, maybe I'll leave myself a little extra room. I could say the derivative of cosecant is the same as the derivative of 1 over sine of x. You might argue that sine of x to the negative 1 power makes more sense, and that's true if you know the power or the chain rule. But at this point, I'm pretending we don't, so I'm just using the quotient rule. The derivative of 1 over sine of x, well, I guess I'd use the quotient rule. Can I start abbreviating stuff? Playing the role of f, I don't know who I was asking there, is the numerator, which is just 1. Playing the role of g is the denominator, which is sine of x. F prime, the derivative of 1, well, the derivative of any constant is just 0. G prime, derivative of sine, as we had written up here, is cosine. Wow, that is all sorts of messy. Take all this information right here. I'm going to fix that up a little bit. Sorry. This is cosine of x. You take all this information and you apply the quotient rule. Quotient rule tells you that the derivative of f divided by g is f prime, which is 0, times g, which is sine of x, minus g prime, which is cosine of x, times f, which is 1. And then you take that whole thing and you divide it by g, which is sine of x, squared. Well, let's see, 0 times sine of x is just 0. So in the numerator, I just have negative cosine of x. And then in the denominator, I have sine of x squared, which I can write as sine of x times sine of x. Why would you do that? Well, a negative divided by a positive is a negative. Cosine divided by sine is cotangent. And then 1 divided by sine is cosecant. So the derivative here is the negative of the cotangent of x times the cosecant of x. I'm trying to remember which order you see that written in a book. I think typically you see negative cosecant times cotangent, but I'll assume that you believe multiplication is commutative and the order that you write those in makes no difference, and I'll leave that as the answer. And I don't know why I erased the box around this thing. I did it accidentally. Put that back. Same logic to figure out the derivative of secant. The derivative of secant is just asking you what's the derivative of 1 over cosine of x. I can do that. I just apply the quotient rule. Playing the role of f would be the 1. Playing the role of g would be cosine of x. And so f prime is again 0. G prime is the negative of sine of x. And if I apply my quotient rule, I say it's f prime 0 times g. I'll write it out. Cosine of x minus g prime, which is negative sine of x, times f, which is just 1. And you divide that whole thing by g squared, cosine of x squared. So how's this simplify? Well, again, 0 times cosine is just 0. Negative times a negative is a positive. This time I have positive sine of x divided by cosine of x squared, which I'm going to again write as cosine of x times cosine of x. So that's easier for me to use trig identities to rewrite this. Sine over cosine is tangent of x. 1 over cosine is secant of x. So what I get is that the derivative of secant is tangent times the secant. Kind of interesting that in both of these cases, derivative of cosecant has a cosecant in it. The derivative of secant has a secant in it. I don't know, just an observation. Maybe that's not so interesting. Cotangent. Cotangent is going to be kind of similar to what I did up here. Really what I'm being asked to do is figure out the derivative of cotangent is the same as cosine over sine. So what are you going to do? Same thing you've been doing. You're going to use the quotient rule. Playing the role of f is cosine of x. Playing the role of g is sine of x. F prime would be the derivative of cosine is negative sine of x. G prime, derivative of sine of x is cosine of x. Plug all that mess into your quotient rule and you get f prime, negative sine of x, times g, sine of x, minus g prime, cosine of x, times f, cosine of x, divided by g, sine of x, squared. What I have in the numerator, if you factor out a negative 1 from both of those, you'll have sine of x times sine of x plus cosine of x times cosine of x. In other words, sine squared x plus cosine squared x. That's just negative 1. Using the Pythagorean identity just like I did in part A. So it's negative 1 over sine squared x. In other words, it's the negative of 1 over sine is the same as cosecant. So the negative of cosecant squared x. Now that I have these derivatives, I can use those, although I guess I don't use them down here till part 8. Also, I think I reference problem 5, but it's really problem 6 where you use those. Anyways, number 7 here says, all right, now you know the derivative of sine and cosine. You can figure out stuff. You could figure out the derivative of x times e to the x times sine of x times cosine of x. This is miserable. I shouldn't say that. I'm going to use the product rule. Playing the role of f, I'm going to choose, and there's some freedom in what you choose. I'm going to choose x e to the x to be playing the role of f. And playing the role of g, I'm going to say it's sine of x times cosine of x. And the reason why is I'm going to figure out f prime here and g prime here, and I'll figure out both of those using the product rule. Right? To figure out f prime, I need the derivative of x times e to the x, and I can figure that out using the product rule. Try to keep this organized. Product rule. I guess this is product rule 1. Well, I'll just write product rule. Product rule, playing the role of f is x, playing the role of g is e to the x. So f prime is 1 and g prime is e to the x. And when you mash those all together using the product rule. The product rule tells you that the derivative of f times g is f prime, which is 1, times g, which is e to the x, plus g prime, which is e to the x, times f, which is x. So I get that it's e to the x times 1 plus x. This is what goes right there. What about g prime? What about figuring out what goes right here? Well, I can do that, but it's going to involve another product rule. Because I'm trying to take the derivative of sine times cosine, so I'm multiplying together two things. One of those things is sine of x. The other of those things is cosine of x. So I can figure out f prime and g prime. The derivative of sine is cosine. The derivative of cosine is negative sine. And so using the product rule, I get that the derivative of this f times this g is f prime cosine of x times g, which is cosine of x. Am I doing this right? F prime times g plus g prime, which is negative sine of x, times f, which is sine of x. So what I have here is it's cosine squared x minus sine squared x. No great simplification you can do there, not like the Pythagorean identity. There might be something you can do, I don't remember, but I'm going to leave it just, there definitely is something you can do. It's trig, there's always something you can do. I'm going to leave it like that and say that that thing goes right here. And therefore, for my answer, I can apply the product rule using these four pieces right here. I can say that the derivative of f times g is f prime, what I have written in red here, which is e to the x times 1 plus x, times g, which is sine of x, times cosine of x, plus g prime, which is what's in green here, cosine squared x minus sine squared x, times f, x times e to the x. This entire mess here would be my answer. Could you simplify that? Sure could. I'm not sure that I want to. You could factor out an e to the x from both of the terms. Beyond that, I don't know, nothing strikes me as super obvious, so I'm going to leave it just like this. Number 8 says, figure out the derivative of secant times tangent, a deceptively challenging problem. You could do this a few ways. You could rewrite secant as 1 over cosine as tangent, and tangent as sine over cosine. But what I said is, rather than do that, use the results of this problem. So up here, you figured out the derivative of secant and the derivative of tangent. The derivative of secant, you, or me, I guess, figured out was tangent times secant. And the derivative of tangent was secant squared. So what I can do is use the product rule, playing the role of f is secant of x, and playing the role of g is tangent of x. And f prime I can get from up here. I figured out the derivative of secant is secant times tangent. And g prime is the derivative of tangent, which I figured out above was secant squared. It's this right here. So what I can do is take these four pieces right here and put them all together using the product rule. The product rule tells me that the derivative of f times g is f prime secant of x times f prime is secant of x times tangent of x. Multiply that by g, which is tangent of x, and then add to that g prime, which is secant squared x, and multiply that by f, which is secant of x. What a mess. If you want, you can clean this up a little bit. You could say it's secant times tangent secant of x times tangent squared x plus secant cubed x. If you felt like it, you could say that this is secant of x times tangent squared of x plus secant squared of x. I'm sure you could rewrite that in lots of different ways. I'm not going to. I'm going to call that good and call this my answer. And move on to the last one. Not a whole lot of room here. Fortunately, I don't need a whole lot of room. This is going to be one kind of like on the first couple problems I did in the other video. We're doing a little bit of algebra, can save you a lot of time. This is asking me what is the derivative of secant, which is 1 over cosine, divided by tangent, which is sine over cosine. Dividing fractions, I got a trick for that. I can multiply by the reciprocal. I can say that this is the derivative of 1 over cosine of x times, and then flip this one upside down and call it cosine of x divided by sine of x. Note that I haven't done any calculus. This is all just algebra. I can cancel out these two cosines and say, really, all this question was asking me to figure out is what is the derivative of 1 over sine of x. Wait a minute, 1 over sine of x, isn't that just cosecant of x? Sure is. So this whole question was just asking me what's the derivative of cosecant of x. Isn't that the same thing that 6 part 2 here was asking me when I figured out it was negative cotangent of x times cosecant of x? Yep. Maybe I'll say C6, 2. So this right here would be my answer, and mercifully that ends this video.